This is question number 14 on the video, and I'm just going to show you a trick. I had said that when you're doing u substitution, u is always going to be the inner function. And the other thing that I said is that somewhere around the derivative of u needs to be lurking in the integrand. And this is an exception. And this is just a trick. So u is going to be the inner function. The second derivative is going to be negative, or the first derivative is going to be negative dx, which is okay. So negative du is dx. So this presents a little problem, but it's not an insurmountable problem. It just requires a little cleverness here. So the square root of 2 minus x is going to become square root of u. And that I can handle. Dx is negative du. The question is what to do with this x squared. We have to write it in terms of x. And the trick is we're going to take our u value and solve that for x. So in fact, x is 2 minus u, so that now my integrand can become 2 minus u, quantity squared, times u to the 1/2, and dx I'm going to replace with negative du. And in order to integrate this, I just need to do a little bit of work. I'm going to FOIL out this 2 minus x, so that gives us 4 minus 4u plus u squared times u to the 1/2 du. I'm going to distribute that u to the 1/2, so we have 4 u to the 1/2 minus 4 u to the 3/2 plus u to the 5/2 du. And then when I go to take the antiderivative, now this is fairly easy, so I'm going to carry along the negative and worry about that later. I'll have 4. This is going to become u to the 3/2, and 1 over 3/2 is 2/3. My next term is 4 times, I know I'm going to have u to the 5/2, and 1 over 5/2 is 2/5. I'm going to have u to the 7/2, and 1 over 7/2 is 2/7. So then this becomes, I'll just distribute the negative, negative 8/3, 2 minus x to the 3/2 plus 8/5, 2 minus x to the 5/2 minus 2/7, 2 minus x to the 7/2 plus c.